hydrogen wave function, psi of r theta phi is equal to RNL into YLM theta phi. It has two parts, that is radial part and angular part. And radial part RNL can be written as U of R by R, and we can put this in this equation. Then psi of r theta phi is equal to U by R into YLM theta phi, where rho is equal to 2 alpha r, then which is equal to 2 mu z e square by nh cross square into r. This can be written as 2 r z by n into mu e square by h cross square, which is equal to 2 r z by n into 1 by a0, where a0 is the Bohr radius and for hydrogen atom it is 0.529 angstrom. Then for ground state n is equal to 1, then the values of L from L is if the values of L starting from 0 to n minus 1. For L is equal to 1, it is from 0 to n minus 1, that means L is equal to 0. And we know that lambda is equal to n, which is equal to k plus L plus 1, and instead of n I put 1, then k plus L is 0 plus 1, that is k is equal to 0. And f of rho is equal to summation k is equal to 0 to infinity a k rho to the power k, which terminates after the first term because k is equal to 0 here. So for n is equal to 1, L is equal to 0, f of rho is equal to a0. Then u1 0, here 1 means n value and 0 means n value, and 0 means it is the value of L. Then rho is equal to rho into e to the power minus rho by 2 a0. And the normalized radial wave function is r10 is equal to 2 into z by a0 to the power 3 by 2 into e raised to minus rz by a0. This for the ground state. Next, for the first excited state, that is n is equal to 2. So n is equal to 2. The values of L ranges from 0 to n minus 1, that is 0 and 1. Then the two possibilities here, that is r20 n and L value. Here r21, that is n and L value. Again for the second excited state, n is equal to 3 and L is equal to 0, 1, 2, and here three possibilities here, and these are the radial function. Normalized radial function, and in general we can write RNL, R is equal to this equation, and here capital L, it is the associated Laguerre polynomial. And probability, now we have to find out the probability to find the particle between R and R plus dr. That is, probability is RNL square 4 pi R square dr, and since Rn comma n minus L, it is proportional to r to the power n minus 1 e to the power z r by n a 0. Then the probability is proportional to r to the power, that is r square into r to the power 2 into n minus 1 e to the power z r by n a 0 into 4 pi r square dr. So here there is an r square, here also r raised to minus 2, here r square, so it will combine and get 1, that is p proportional to r to the power 2n e to the power z r divided by n a 0 into 4 pi dr. So this is the probability. Now degeneracy. Degeneracy means the same energy state, same energy level. Okay, so it's the most important feature of the hydrogen atom. It is the degree of degeneracy, that is the number of linearly independent states with the same energy. So for each n, the allowed values of L are L is equal to 0 to n minus 1. So for each L, there are 2L plus 1 states specified by the m value. We know that if L is equal to 1, the m values are, m states are 2L plus 1. Okay, if L is equal to 1, then it is 3 values are there, or 3 states are there, that is minus L to plus L. Okay, that is, here L is equal to 1 means it is minus 1, 0, plus 1. So 3 values for m. Thus the total degeneracy for a particular n is summation L is equal to 0 to infinity 2L plus 1, which can be written like this, and which is equal to 2 into n minus 1 into n by 2 plus n, which is equal to n square. So the total degeneracy for a particular n state is n square.